Hi everyone, in this video clip, we are going to discuss the differentiation by the first principle. Now, before we proceed with the first principle, let's study what does differentiation means. Now, basically differentiation refers to the rate of change of one quantity over another quantity. So a rate of change. Now, let us use the straight line graph to study the concept of rate of change. So if from point A to point B, okay, we will experience the changes in terms of X and Y. So the rate of change will be, we want to know how much the Y change as the X changes. So that is the rate of change of X over the Y. And that is actually the gradient of the straight line, the gradient AB. So the formula of gradient, to find gradient AB is y2 minus y1 over x2 minus x1. So from this formula, we know very clearly that to find the gradient, we need 2 points. We need 2 points. Now, let's shift from straight line graph to a curve. Okay, given the curve, and then we need to find the gradient of the curve at one point, let's say point A. So what is a gradient of the curve at one point? Crazy, isn't it? Because we know that to find a gradient, we need 2 points. And yet the question wants us to find the gradient of the line of the curve at one point. So actually that also refers to the gradient of the line that touches the point, touches the curve at only one point. And this one, we call it tangent. So we are looking for the gradient of the tangent at point A. So how do we find the gradient when we only have 1 point? Therefore, we create another point that is very close to point A. Okay, so we slide either up or down and come to a very close point. So these two will form the straight line in between them. Okay, so this will be the changes. So we slide a very small value towards the right, and therefore there will be a corresponding small value upwards. So if point A is xy, the point A prime here will be x plus delta x and y plus delta y. Okay, so to find the gradient, all right, we shall take the y2 minus y1. So y plus del y minus the y here, the y of A, over the x coordinates of A prime, so x plus del x, minus the x coordinates of point A, that is x. So it's actually taking the ratio of the triangle form here. So the gradient of AA prime, okay, AA prime is equivalent to del y by del x. However, we still have not answered the question. The question wants us to find the gradient of the curve at one point, at point A, only 1 point. Okay, so how? So we will get that straight line instead of this purple straight line. We need to get back this blue straight line. So what do? We have to make sure that del x is so small that it's almost 0. When it is almost 0, it is not moving at all from point A. Therefore, the gradient of the tangent will be exactly equals. Okay, before we do anything, it is only approximately equivalent to del y by del x, because del y del x is actually the gradient of AA prime, not A alone. So the gradient of tangent will be exactly equals when we set the limit of our del y by del x when del x approaches 0. That means when this one is almost 0, it is as though as the point A never moved. So this is how we find the gradient of tangent of the curve by using the first principle. So to be more specific, let's use y equals to 3x squared plus 5x. Okay, to illustrate this example. So again, to find the gradient of the tangent, let's create a very close point to our original xy. Yeah? So that will be y plus del y equals to, we substitute the coordinates of x, all right, to the function. So we have x plus del x squared plus 5x plus del x. Let's expand the expression. So we have x squared plus 2x del x, and then plus the square of del x. Okay, and then plus 5x plus 5 del x. And let's open up this bracket where 3x squared plus 6x del x plus 3 del x squared plus 5x plus 5 del x. And notice that 3x squared plus 5x is actually y. So y plus del x equals to y plus this. Therefore, the del y definitely equivalent to 6x del x plus 3 del x squared plus 5 del x. And remember, we need to find the gradient. So del y by del x. Divide both sides with del x. So we will have del 6x plus 3 del x plus 5. Okay. We have not answered the question yet. The question is asking us to find the gradient of the curve at one point. So that will be the exact gradient. So dy dx will now be exactly equals to our del y del x only when we set the limit of del x is very much close to 0. And therefore, when del x is 0, we left with 6x plus 5. So this is how we use the first principle, why we have to add del y and del x. And next step, why do we need to divide by del x? Because we are looking for the gradient. And then from that gradient, we let del x approaches 0, and that will be the exact gradient of the curve at just one point. Okay, so that's it for differentiation by the first principle. Should you have any question, please leave your message at the comment area. I'll come back to you as soon as I can. Thank you.